Welcome to Stay Sharp in Digital Engineering, your trusted guide to navigating the future of digital innovation in products and manufacturing. In this episode, we continue our series in digital twins. This time, we explore digital twins in hardware, zeroing in on PDM's role of version control and beyond. We tackle ECAD, MCAD, and the art of keeping all the data in sync. Let's roll. Well, welcome back, everybody, to Stay Sharp in Digital Engineering, the podcast about all things digital related to products, engineering, manufacturing, service, and beyond. I'm one of your hosts, Juliann Grant, and today I'm joined by my co-host, Jonathan Scott.
Hello, everybody.
Good morning, Jonathan. So today we're going to continue our series about digital twins. We did kick that off in a previous episode, and we did some level setting and shared some terminology around digital twins. And with each one of these installments, we're going to want to look at the different elements that are important for building a valuable digital twin. So we want to be able to also provide context of what you might or might not need around these various components based on what you're trying to accomplish with a digital twin. So with that, Jonathan, let's kind of jump right in about today's topic.
Yeah. I think this is fun that we're taking these kind of piece by piece because there's a lot to tease out and peel apart. And the one we wanted to start with today is about hardware, right? And that's not the hardware itself, but the digital piece of the hardware of whatever the product is, because that's a big part of the digital twin that a lot of people think of. It's not the only one. And that's if there's one thing people get out of the series, I hope it's that each of these may feel like you have to have them, but it's not the case, right? Some people are going to have a digital twin that does not have hardware. So, for me, it's near and dear to my heart. I think it's a big thing, but, it's not a part of every digital twin that we need. But what are we talking about? We're talking about all kinds of different hardware. And I guess we'll dig into that a little bit as we go.
So where is that typically stored, Jonathan?
Yeah.
That data. I mean, you think about hardware and you think, oh, it's kind of static, doesn't really change all that much. But my guess is it changes a bit. So
yeah, I think that's right. And of course, that really varies by industry, how much it's changing, how fast it's changing, that kind of thing. But to your point, where is it stored? What are you doing with it? How are you going to get it to be able to use it or put it in your twin? And I think the answer that a lot of people will expect, and I think is right, is probably in a PDM system, a product data management system. And that could look a couple of different ways. It might be a PDM function within some other software, right? So there are some ERP systems that can manage some of this hardware data. A lot of times there are PLM systems, product lifecycle management systems, that'll manage, do the PDM capability, have PDM within it. And they're dedicated PDM systems. Sometimes they're add-ons to CAD tools and things like that. But that's frequently where it's going to be. Sometimes it's going to be on a file system, right? Sometimes people are just going to be stored on their hard drive, on the network, on a cloud app or something. But a lot of times it's PDM is where you're going to want to find this stuff.
Right. When I think of PDM too, I think of that sort of as the original place where PLM kind of started.
Right.
And then it's grown from there.
I think that's right. That it has been the building block, and it makes sense, right? Because a lot of this world of digital definition of products grew out of that mechanical CAD world and some other CAD domains. But and that's where it all got its start, right? As we started making better and better models of the physical design of the thing, and then realized, well, if you've got digital models, suddenly they're a lot easier to manipulate than drawings were, than paper drawings were. And once it was easier to change, then you made a lot more changes, which meant you made a lot more files, which meant you could have a mess. And so you need a system to manage it. And so I think that is how we got sort of where we are today with this. And it's points out an integral component that you need to keep track of it. And I think that's probably worth digging into for a minute.
Yeah. So what are those things that you might want to look for in a PDM if you're trying to build a digital twin?
That's a good question, and I think the right place to go with that, right? After you think about where do you keep this stuff? Well, what's important about PDM? Why not a file system, right? And
I'm sure some people still using Excel out there,
Yeah, right. And it is. You could turn it into a little PDM system, and that gets right to this point. Like instead of talking about the PDM systems themselves, what are the capabilities they're bringing that we need for this? And I'll note the things that I think we could talk about here that you need for your digital twin are not exactly the same as what commercial PDM systems and PLM systems do. Usually those systems do more, right? But so let's talk about the key things that you need to have. Well, you need to have your files stored, right? Most of these systems that create models of your hardware are going to make files. Now, they're not all going to look the same, and we should come back to that to talk about like formats and domains.
I can imagine a myriad of file types there.
Yep. But by and large, it's going to be files you need to manage. Even the systems that are starting to think about managing these models in databases, the database is still a file somewhere. So anyway, so you need to manage files. You need to also manage versions of those files. I mentioned that a second ago. When we got to this digital world, suddenly it's much easier to change than paper, right? You're just flipping some bits and electricity. So suddenly a design that starts off, a bracket looks a certain way. Well, it's easy to say, it's got sharp corners on it. Let me chamfer those. Now I've got another version of that model with the chamfers on it. You know what? It was much easier with an internal radius on that piece to go ahead and make it a radius and not a chamfer. Okay, let's switch that. Another version. You get the idea. We keep making new versions of these pieces of hardware, and that's the way things evolve, right? And I think you mentioned it earlier. Software probably changes faster, but hardware still changes. And people are still changing and evolving their hardware parts of their product. So you got to keep track of the different versions. Again, most file systems can do that. But like you said, Excel, people started to use that. Let me track which version is which file name and kind of the order of them and that sort of thing. That gets us to another really important thing that you need out of a PDM capability, and that is configuration management. So if you can keep track of all the individual versions of the files, most of these design systems that create models of hardware are going to have file interrelationships. Mechanical CAD is a great example, where an assembly model actually links to all of the part models that make it up. And then on, right? Assemblies to subassemblies onto parts, so that kind of thing. But what that means is if all of those files have versions, you have to know which go with which.
Well,
and that's
right.
the CM piece.
Exactly. All of a sudden you start having these multiple, you said there's iterative processes happening as the hardware gets developed. Maybe something gets added and then you have a new version. So
right. And you've got, maybe independent teams working on it, right? And you need to integrate that. All right, this team worked on the motor, this team worked on the batteries, this team's working on the chassis, whatever it is. You've got to know how to put the right versions, right? Because they're working at different points in time, maybe different parts of the globe, et cetera. So that CM piece is critical to making sure you've got the right versions that are supposed to go together, that have been checked or validated in some way. So that's another really important PDM capability.
Yeah. So, do most PDMs include a configuration management capability in it, or not always?
Yeah. No, most all of them do, because that's that key capability they've got to have. You've got to be able to keep your model straight so that somebody who's designing a system or a piece, they can hand the PDM system, hey, here's what I worked on. I know all this works together. The next time they come back in, they need to get that back instead of, hey, let me just hand you the latest version of all the files you're interested in. That wouldn't work so well if somebody's been working on things independently. So yeah, most PDMs do that.
Okay. The next thing I think about, though, is, in a configuration management, there must be some sort of bill of materials organizing this information, or I don't.
Good question. And I think this is another great lead into maybe a topic we should cover after this about formats, which is a bill of material in PDM. Lots of them will have it, and some of them won't, and it's not essential. But you're right; it's a good tool to have when you're thinking about digital twin, when your product is multi-domain or multidiscipline. And this is, I mentioned getting into this a minute ago. We should get into this. But the reason is that bill of material can represent electrical components, mechanical components, pneumatic, hydraulic, optical, like all the things. So a bill of material can be across your whole product and any domain, whereas design tools, it might be mechanical CAD has got a bunch of the design in it, But electrical CAD has got all the components you're going to put on a circuit board. Or, your optical CAD is going to have those elements, which might fit back into your mechanical somehow, but, you're going to design them and have the details of them in the optical system. So, yeah, I think bill of material can be helpful, can be important. It's not, you don't have to have it if you can integrate all these hardware models yourself into your digital twin, but it certainly is a helpful capability.
Okay. So that's where the acronyms BoMs, MBoMs, all these different types of bill of materials that you're referencing, they all have their own structure, and then they go into a bigger structure.
Yes and no. I mean, I agree with some of the concepts you're saying there, right? Which those are more the domain-specific ones, right? So like the EBOM, MBOM, SBOM, all that stuff, those are, what's the right way to describe it? This always gets tricky, but I think those are like discipline-specific, engineering, manufacturing, service, or sales, other things. But your point is still right on target, right? Which is you will have chunks of bill of material that need to get integrated together to make one master engineering bill or manufacturing bill or whatever it might be. So the concept, that's right on target.
Well, keep going then on these different formats and, help me get a clearer picture.
Yeah. I think that it's good to dig into this because it's not obvious that a mechanical CAD system, and I'll generalize for a lot of the ones that I know out there today, and I know they're not all quite like this, but are going to have one file per component that you might have in your hardware. So one file for a nut, one file for a washer and for a fastener and for a bracket and for a motor and a this and a that. And then you're going to put them together in an assembly file like we talked about earlier. You're not actually making copies of all that data of the geometry of the nut or the bolt. The assembly is just pointing to the other file. So you have to have them both, or have to have all of them, to actually see the assembly of all the components together. Makes sense. Good model, right? Okay. There's no duplication of data, so very good. Electrical CAD is different. Still, not doing the duplication of the data, so they do it in an efficient way. But what you're designing is, with electrical, you're designing the logic of how you want the thing to behave. So I'll use a printed circuit board as an example because I'm not an electrical engineer. So chip design and things like that could be a little bit different, and I'm not familiar. But so for a printed circuit board, you're saying, look, I've got these electrical components that perform these functions, or they have this logic to them, and I'm going to combine them in a certain way to get the whole design, the whole printed circuit board, to behave a certain way, right? You can imagine like a computer board or something that's got a chip doing processing, but maybe it's got a component for a jack or a connector like a USB-C, and then maybe a different jack for power. And so they're putting all that stuff together in the design logically, and that's a schematic. Oh, this connects to that. This connects to that. The input here is the output there, that kind of thing. But then you need to say, okay, if this is how it all gets logically connected, what does that mean physically? Where do I put the chip? To make all those connections, maybe the chip has to go in the middle, and because it's only connected to something external, that jack, that's the USB-C jack, has to go on the outside edge. Okay, so now I need to take all these logical connections and put them physically onto maybe as small a PC board as I can make, right? Because a lot of times you're trying to just get it down in a little tiny package, like to fit in a cell phone or something.
Small footprint kind of a thing.
Exactly. Or you're needing to think about thermal, right? Oh, well, this power thing's going to get hot. I don't want to keep it next to this other component. So you got a lot of trade-offs to make. But ultimately, that ECAD system is making a physical design that is paired with or integral to that logical design that gives you the functions you needed. Okay, but file-wise, how does that work? Well, each ECAD system is going to be a little bit different, but they're going to have these, like a project that, much like the mechanical CAD, where I said, oh, there's assembly files, part files, sub-assemblies, all these things, and you need the collection of them. Same thing here. ECAD files, they need the whole project. But they might have a library of components they're referencing externally, and then one schematic file, another schematic, each one for a different layer, or maybe all in one file. They can decide, right? They do it their own way. But the point is, you're not breaking it out in the same way that mechanical CAD does. So it's just different, right? They manage it differently, but they still need some PDM to keep the right versions of the files together in the right way, to give you the right version of the total design that you're looking for. So they're similar, but they're different. And I use those two as an example. I mentioned earlier, optics, hydraulics, pneumatics. If they're chemical elements, like let's say you're talking about batteries, right? There are lots of different domains of physics that lead to different parts of a hardware design of a product. And they may all have their own tools and their own models and things. But when we're talking about a digital twin and how we get these models, this data together, that concept is the same, right? So take my mechanical electrical as just an example of what you need to do to have the right models for your digital twin.
Right. Okay. So in the ECAD side, does that create a 3D model, or does a 3D model get combined with the MCAD so it's all one?
Great question, right? This is where things get really tricky. They get really tricky too. That's all, folks. So they get tricky because you are trying to figure out what do you need? What model do you need to do the job that you're trying to do? And we're talking about this in the context of digital twin. So if you want a physical model and your digital twin needs to look at the 3D, then maybe you have to make 3D of your electrical design, whereas the ECAD system itself didn't or doesn't. So there are lots of tools that kind of sit in the middle and help navigate all this that people sometimes need and sometimes don't need. It comes right back to what you said at the top of the episode. You have to think about the purpose you have in mind. So you might need another PDM capability, which is creating derivative outputs, derivative formats. Hey, here's what my ECAD system made, but I'd like to run that through an engine and make an interchange format to help it interchange 3D. Or I'd like to have it output some data as a PDF because that's more readable. Like in the mechanical world, it's let me output it as a step file or some neutral file that doesn't have all the design information, but it has enough information to be used somewhere downstream, which is what you're often thinking about with a twin.
Interesting. So the thing that comes to mind for me now is we have all these data,
tons and tons of pieces,
data.
right?
tons of these pieces of data, correct. So how do you manage that sync between the data and the different versions? So you talk about configuration management, you're talking about, managing the various versions. So in one version, the chip might be in the middle, and another version, the chip might be off to the right. How does this all get managed from the PDM side, to help support that twin?
Yeah. Well, you said a good key word about sync, right? Because a lot of times those different domains of design may not be in sync. You might be way out in front with your electrical design, and then your mechanical is going to catch up at some point. And if your product design is very serial, maybe you don't have a big issue, right? I finished this piece, and then that's input to the next thing, and then I finished that piece, and it's input to the next thing. But today's world, everybody wants to do things faster and in parallel, which means now you need to think about doing it in sync or syncing up at certain points. And the question you asked earlier about bill of material can be one answer to it. It doesn't have to be the only one, right? But you can kind of sync up on, all right, my mechanical piece fits into the bill of material here. My electrical piece fits in here. Remember, there might be overlap. That's where it gets fun, right? Like a motor. Okay, there's a mechanical model of the motor because it's big. There's an electrical model of the motor, how it behaves, what voltage, what power does it need, that kind of thing. So you have to consider that in the sync, which might lead you to some of that 2D, 3D stuff we talked about. But end of the day, you need to configuration manage the whole thing. That might be, a PDM for mechanical, a PDM for electrical, and then I've got to use the bill of material to rationalize all that or sync it. Or we talked about, PDM capabilities might be inside of a PLM. Okay, it's another possibility, right? The PLM brings it all together, and it has PDM for electrical and mechanical both. So a lot of different ways you can solve the problem, but your question gets at an important capability you need, which is you have to be able to bring it all together, configuration managed, so that it's not, I had the best electrical design, but I had the wrong version of the mechanical design. And when I try to put it together in the twin, it doesn't represent the product that I was making, right? And this is where you could get back to the BoM question you asked about earlier. EBOM, MBOM, are you using the right versions in all of those? Because maybe you built something that's different than what you intended to.
Well, it's sounding like there are just what might happen is different instances of a twin get created based on, what people are looking at. And so, when you're first talking about configuration management, I was thinking, well, then that's clear. That's probably where the outputs of a digital twin come from.
Right.
But maybe not.
Yeah. Well, and when you said instances, that's exactly right, because what you might want, and a lot of times what you do want, is you want a twin that reflects the particular way you built it on a Tuesday, right? And that doesn't mean it's the latest. It means it's what was being built on Tuesday. So it's some older electrical component and some older mechanical component because it was before you changed it when you fixed and found a problem on a Wednesday. And, today it's Friday and, well, we're going to build it differently today. But that is part of what configuration management is, right? Is not just get me the latest. It's get me what I want. Get me the accurate representation of whatever it is I'm asking for.
Right.
And that's a key piece of digital twins, right? Because you need to be able to get what you're looking for, not just the latest or best.
Right, because I think most people, well, I'm not going to generalize for most people, but the way my thinking works is, when you think about what you believe a digital twin should be doing, it should be, not just existing in its instance, but also providing feedback and, doing some level of, helping people with quality or understanding maybe a problem happened and you want to understand, what would that particular configuration look like to make that correction and then create a new version. So there's all these different levels and layers of digital twins that just make it complicated. And I think it might be hard for teams to really get their arms around what is the purpose of these twin instances.
Yeah, you're exactly right. It comes back to something we mentioned at the kickoff episode of this series, and I'm sure we'll touch on every time we talk about it. And that's the purpose. Knowing the purpose is going to tell you a lot about what you need, but it is pretty clear that this configuration management piece, you really are going to need, if you need anything below it. If you need the models, you have to get the right models.
Well, we were talking about, we're talking about all these different instances. And can we just expand a little bit about, or help me think about the feedback aspect of digital twins and how that might get used? I mean, we think about the syncing of information and all those aspects of that have to be managed in a twin or in a configuration management capability of, in a PDM. Well, where does the feedback live? How does it get back in? What's most important?
That's a great question, because I don't know that there's a perfect answer to this. And the feedback can be a tricky term when we're talking about twins, because, my mind immediately jumps to a true digital twin or even a digital shadow where there's feedback from the physical world, from IoT, IIoT, those kinds of things. A
sensor, something.
Right, a sensor, exactly. And that's, good topic for another episode on this. But that kind of feedback, and that's tricky. There's a lot to that. So save that for later. But then there's the kind of feedback that is, I'm just, I'm testing it. I made a PC board. I sent it to the test lab. I want to know what the max power input is before it smokes, that kind of thing. Okay, so I go do that test. I get that data. Now, what do I do with that? In some cases, to your point, it's feedback that is going to go back into the design model, and it's just another revision, and it's that configuration management piece we talked about that takes control, gives you the right information. But it gets awkward when we're bridging this gap between the virtual and the physical. So when it's fully the physical and you're making 10,000 of them, then we're talking about IoT sensor data, that kind of thing, coming back. How do I manage that and correlate it with my configuration managed digital models? But the one in the middle is, I don't know, does it go into PDM? Is it a PLM thing? Like if I go measure my physical instance, but I'm only measuring one of them, so it's representative. So I mean it to go kind of to my virtual model, and then will I have more details for every physical one I make? And that feedback piece, I think, is a big question. How will you incorporate it? Where will you keep it? there might be people today where that data lives in a quality management system. And you have to think about how to configuration manage that data with your PDM CM data to decide what to put together for your digital twin. So it could get tricky, but it's a great question to think about.
Right. Well, and the other thing that also comes to mind is in this testing viewpoint, is simulation, right? So there's a whole side of simulation that's applied here to help manage that testing, to understand when it gets too hot or when it's not working or when things are going to fail at what point. And so, that necessarily might not live in a quality system because it's not in an actual, delivery of a final end product, right?
Yeah, two pieces of testing to your point. There's simulation, digital testing, and then there's physical testing, right? Literally put it on a lab bench, hook up the wires, or stick it in a thermal chamber, or whatever it might be. And those are two different animals. The physical tests might not even be QMS, like I said, right? If you're measuring something, maybe it's in QMS. Physical tests might be in a LIMS, laboratory information management system, that you're trying to correlate back. And to your point, we're lining up the episodes here. This is great. You might be tracking the simulation data in SPDM, SPLM, simulation data management system. So depending on the kind of test, might determine where you keep it and then how you incorporate it back into your models.
One thing that comes to mind in this discussion is that we really haven't touched on, but we were talking about testing, is this, the whole concept of simulation and simulation applications that really go deeply into testing different configurations of different products before it goes to market, right? So to help identify, when it's going to fail, or what materials are needed, or, what gets too hot, that kind of a thing.
And those are maybe even the first kinds of digital twins before we started calling it that, right? Which is where we start to put together multi-physics simulation of, hey, you put these different things together, how's it going to behave? Because I can't really predict it otherwise. But your point's a good one, as we were talking about the way that feedback from the real world gets into your models. There's the IoT and IoT kind of approach, but then there's if I'm just doing physical testing, maybe if I'm testing the size and shape of something that's in a QMS, I'm recording, measurements, photogrammetry, whatever that might be. But if I'm doing it in a laboratory and I'm putting enough power on it until it smokes and I want to know that max power, and somehow that's going to make it back to my design model, that maybe is in a LIMS, a laboratory information management system. So, and to your point, digital testing, simulation tools, that might be kept in an SPDM system or an SPLM system, something like that. I think every one of these we should get into, like, how do they fit into your digital twin, or what do you do with them? But the question, it's a bigger question we're probably going to answer on this episode, which is, what do you do with it? Some cases you might take it back to PDM, which is why it's worth talking about here, right? Some test data goes back to your design model, and then that's how it finds its way into your twin.
Okay. Yeah, I mean, it just opens up a whole nother door of conversation there.
It does, right? But that's our whole point, right? Is we know we've got a bunch of these we can talk through.
Right. Yeah. So given that, I think we've covered quite a bit of territory today. And so thank you for helping me understand more clearly about the role of PDM digital twins, the importance of configuration management, and understanding how all these various pieces fit together to eventually create an output of a product that gets sold. So
and I think to the premise we were kind of starting with here is this element, the hardware. If your product has hardware and that's a part of the digital twin you care about, what do you need to get that into your digital twin, right? And I feel like we did a good job touching on that, I think.
Yes. Yeah, you mentioned digital shadows. We talked about virtual and digital twins and different instances of digital twins to represent the different, geometries or electromechanical. So that does make hardware a lot more interesting. I mean, when you think about hardware, sometimes you think, oh, that's not that interesting, but it actually is very interesting.
And if your product is hardware-based, probably a key point of the digital twin you're going to make. And so you have to think about, how are you going to get that into that twin that you want to build?
Right. Okay, well, thanks so much for this conversation, Jonathan, and we look forward to the next version episode that we cover on digital twins. And we're open to your comments and input on what we should be covering in this digital twin series, because we know that there's things that we might be thinking about, that you might be thinking about as a listener that we're not thinking about. So we would love that input. And we always welcome your questions and comments. And we hope you continue to tune in with us. And thanks so much for being here with us today. And thanks, Jonathan, for spending some time with me on this topic for digital twin.
Absolutely. I'm looking forward to the next one. I don't know which one we'll do next, right? We got a bunch of ideas we talked about today, but it'll be fun.
Yes, we keep outputting new ideas. But with that, we thank everybody for their time today. And until next time, stay sharp.
Thanks, everybody.
Thanks for being here and listening to this episode of Stay Sharp in Digital Engineering with Razorleaf. If you like this podcast, please be sure to hit the like button or subscribe to our podcast on your favorite podcast platform, or check us out on YouTube. If you have any questions or have more ideas around topics we should be covering for our digital twin series, please leave us a comment or send us an email to podcast@razorleaf.com. We'd love to hear from you. Until next time, everybody, stay sharp.